All right, great. Can you all hear me? Okay, fantastic. Thanks so much for the invitation to come speak. This is the perfect venue. I couldn't be more excited to be here and be meeting all of these new faces and seeing old friends or friends that I've only met online. My name is Jessilyn Dunn. I'm an assistant professor at Duke in biomedical engineering and biostatistics. Today I'm going to be talking to you about a tool that I hope everybody is interested in some way. Many of us are working with wearables or with digital health tools that we can use to collect data. And we know that these tools are only increasing in form factor, in availability, in types of data that we can collect. And through that, the future of this field is huge and really immense in what we can do. And so what many of us have been doing here is developing digital biomarkers from the data coming from these tools. So I'm going to be very explicit in what I mean here by a digital biomarker, in that I'm talking about digitally collected data, so a continuous stream of data. For example, that could be continuous location from a smartphone GPS like we saw yesterday with the Bayway platform. This could be a continuous ECG or PPG signal on heart rate, and we transform that in some way using mathematical transformations to create an indicator of a health outcome. So that could be a binary outcome of sick or not sick. That could be a continuous outcome, for example, of predicting a blood glucose value. So what this looks like is we have some, let's see if this works here, we have some target outcomes. So this would be sort of the output of our machine learning model or our statistical model. And we've got some function that we're developing around measurement. So these are these continuous streams of data. So just out of curiosity, for how many people in this room is this framework familiar in what you're doing? Awesome. So we are all in this community together, which is great. Because I think one of the things that we really can leverage at this point is our shared knowledge. So because we are all developing something of this framework, a lot of us are spending time reinventing the wheel. So, coming up with new outcomes or new metrics, coming up with new ways of developing features from these measurements, new functions. And we're not leveraging this shared knowledge to the best of our abilities. So we've been working toward this platform that's an open source platform called the DBDP, where the goal is exactly that, to leverage our shared learnings and our shared knowledge to build upon the work that we all are doing in the digital biomarker discovery space. So rather than reinventing the wheel and starting from scratch every time we have a new digital biomarker project, we can build off of work that we've already done. So the idea here is that we have an environment sharing data, code, and algorithms. And there are complications to the data portion of sharing, which we heard earlier from Rosalind Picard, and some of these issues that we can focus toward federated learning processes to address. What I hope will come out of this talk today is an excitement for using DBDP. I'll actually ask you all, if you have your laptops here, to get them out, because I have a very quick hands-on example where you can actually see what it would look like to take your projects that you're developing, build a use case on the DBDP, and have other people leverage your code. Benefits of this are people are going to cite your work, and also people will make your projects better. So we found that through these collaborations, we come up with an initial code set, and somebody else will come in with a better idea and make our code even better, and the project is far accelerates what we could have ever done on our own. So right now, we've got some modules up, and my hope is that at the end of today, we have another workshop tomorrow at AMIA for anybody who may be at that conference as well. We'll have a lot more modules that will be coming online. So some examples of these are data pre-processing. So if we're thinking about electrodermal activity, for example, we link to the EDA Explorer tool that's been developed out of Media Lab. If we're thinking about methods to process PPG or ECG at different sampling rates, there are tools for that. And one of the most important parts of this, and this is something that we talked about yesterday as well, is the need for extensive documentation. So the hope is that as a community, we can continue to build up what don't we know, and where is documentation needed so that we can continue to learn as a community. So with that, there's documentation and user guides and ways to contribute, in ways to submit issues, and the hope is that as we start to get this knowledge together, this platform becomes better and better. And if you don't know where to start, if you're like, I'm totally confused, I have no idea what you're talking about, I work in digital biomarkers, but I wouldn't know where to begin. Here's a small roadmap to get started. If you are a primary data collector, maybe you're a clinical research coordinator, you're working in a lab where you have your hands on wearables or mobile devices, we plug in currently to OpenM Health, and there are a variety of other tools that we're currently working on integrating. You may have an idea for a tool that should go here that can actually pull in data. We've been building methods from Garmin and Fitbit APIs. There's the Bayway platform that could also pull in data from smartphones. So there's a lot of opportunities to add here, but currently we're using the OpenM Health shims. If you already have data, you could plug right into the digital biomarker discovery pipeline. So this is the code that you would put the data into. If you don't have wearables and you don't have data, but you develop statistical methods, so you need some data to work on, we have sample data on this digital health data repository that you could actually use. If you have no idea where to start and you have no idea what I'm talking about right now, that's totally okay too. We have this section called DBDP Ed. And part of this is to try to educate the broader community about digital health tools and digital biomarkers, to say, you know, what does this data mean? What are possible ways that we can use it? We know that we can do infectious disease detection, we can do arrhythmia detection, we can look at mental health aspects. There's a lot that can be done. If you have a project where you would like to communicate to a broader audience, from K through 12 students all the way up to the broader community, we write blog posts on a media blog that all exist on this DBDP Ed. So that's another way to contribute. So I mentioned that it would be great for you all to take out your laptops. I have 2 case studies, and I know this is a short talk of only 25 minutes, so there's an option for you to follow along, but there's also an option for you to just totally sit out the collab notebooks and just see the slides. The 2 case studies that I'll be mentioning are direct ways that you could use code that already exists on DBDP with your own data. So one of these would be a validation of heart rate measurements from wearables, and the other one would be a validation of a sleep detection algorithm from wearables. So the first case study, if you want to follow along on your own, again, there is no requirement to do so, it's just a nice example. If you go to bit.ly/dbdp_ECG. That will pull up a collab notebook. I've been noticing that it took a little while to load here, so give it a few minutes. And you can actually walk through what it would look like if you have a smartwatch and you want to know how well does my smartwatch compare to an ECG, what we'll call gold standard. So you might be wondering, what do I mean by ECG and PPG? So PPG is the green light on the back of the watch for those who haven't used it. Sometimes there are other colors that are LED sensors, but this is using optical methods of monitoring for heart rate as compared to an ECG, which uses the electrical signal in the heart. So an ECG is more common in the clinical setting. You'll often see it as a Holter monitor or a chest patch, but these days we also see it in Apple Watches and Fitbits that you can actually hold the crown, close the electrical circuit, and get measurements that way. So we're comparing these 2 different modalities of measuring heart rate. And so what this study looked like, so we're working with actual data here, is we had 53 people come in, and we had several questions at the outset about is there an effect of skin tone on heart rate measurements? And part of the reason for that, we've seen lately with the pulse ox that these optical technologies can be impeded by melanin. and darker skin has more melanin, and so this could potentially be an issue causing noise in measurements. We also know another source of noise is activity or movement, and so this is another thing that we're looking at. And so we had a group of devices that we measured here comparing to a gold standard. So what this process looks like, if you're following along on the collab, is there's an import of data where there's pre-processing steps that happen, and I'll talk in more detail about that pre-processing in a moment. We've got the ECG data, so we have these two separate continuous data streams, PPG, that optical signal, and ECG, that electrical signal, so two separate pre-processing steps. We extract heart rate from those data. We resample and merge all heart rate data together from PPG and ECG, perform a manual alignment, and then visualize and compare across devices. So these slides are a bit out of order in that if you are trying to get on this, you may need to sign in to Google, and you may want to copy this to your Google Drive. So again, this is bit.ly/dbdp_ECG. The ECG pre-processing module is probably something that you've all seen before. Again, this is a standard module that instead of somebody having to figure out how should I pre-process my ECG, it's basically already there in a module on DBDP. And ultimately, what this will look like when you go through the whole process of running the collab is you'll see that you can compare the data from the different devices at the individual level and on the population level. So you can actually see if I wanted to compare, for example, my Apple Watch to Garmin, or these are difficult to see. We've got the Empatica to ECG. Actually, each of these are to ECG. So we've got Apple, Garmin, Fitbit, and Empatica. So this is just an example of a way that you could perform that analysis. You can go through and tweak this code. So you can put different data here. You can use different code, however you want to do this analysis. This is just a skeleton to start from. The key takeaways from this study, and hopefully you can see that through the data, you can also check out the publication if you're interested, is that we see differences in heart rate accuracy across device types. Obviously, the study is old. We know that there have been lots of changes to the devices, the algorithms on the devices. It's essentially, it's the framework that lives on. It's not the underlying data itself. We know that during physical activity, we see a decrease in heart rate by about 30%, which is pretty wild, actually, when we start to think about the implementation of these devices in real-world settings. If somebody is trying to monitor their heart rate under certain physical activity circumstances, it can be really hard to trust the PPG. Although algorithms are continuously improving, again, this is an opportunity for us to work together as a community to learn what works and what doesn't. And we were really glad to see that there was no change in accuracy on skin tone. And so again, that paper is published, and there's more to read about there. I know I'm speeding through this, so if there are any questions really quickly, I can pause for a moment. Okay, I'll move on to the second case study, just so that you've got the materials. Again, there's no obligation to do this, it's just an option. The other case study is at bit.ly/dbdp_sleep. And the idea here is that we're building a sleep detection algorithm that is using data where the sleep times might not be regular. So this data came from a study that we performed in a group of police cadets. So these are inherently people who are doing shift work. People started out on a usual schedule, and then depending on where they were in the training, shifted to a shift work schedule. So we have data on these people in this study. There were 66 people in this study where they were sometimes sleeping at night, at what we would consider to be a regular circadian schedule, and they were sometimes sleeping during the day, which we would consider to be an irregular schedule. And we were using the Garmin device for this study, and Garmin has an automatic sleep detection algorithm. But what we noticed when we started working with this data, and you can see this if you go to this CoLab page, is that there were days where it appeared that people just weren't sleeping, which is impossible, right? We are not going to have people going 48 hours or 72 hours with no sleep. So it was clear that something was missing here. And so what you can see is that with this method, we can leverage existing data to impute sleep times. So if you follow through that notebook, you'll see that we have, and what I'm pointing to here is this is the normal circadian rhythm. So we can see the block of sleep here, where the y-axis is dates and the x-axis is time. So we would expect in a normal circadian rhythm that people are sleeping at nighttime and there's no sleep during the daytime. So what we're seeing is these missing sleep segments here. And so with that imputation algorithm, what you'll see is that we can capture when people were sleeping on off hours. So we can assume that that proprietary algorithm that we didn't have access to was using clock time as part of the way to determine sleep. Whereas we know for people who do shift work, that's not going to work. So we can leverage existing data to better decide when somebody is sleeping. And what we can see then, and we saw an example of sleep regularity index, which I was really glad to see in previous talks as well, is that we can see a really big difference in sleep regularity index in people who have a normal circadian rhythm, where we have much higher regularity in sleep, versus those who have a more disrupted circadian rhythm, so those who are on shift work. So I know I've really sped through this. I'm trying to allow some time for questions as well as some time to check out the notebooks. But you may be wondering, okay, this is all great, but what happens next? Where do we go from here? So there are lots of ways to get involved with DBDP, and you may have other ideas. So I really would love to hear from you all what you think is missing in the community and what you think could work for you. But ultimately, we are all working on code for the most part. So this is an easy way to contribute. If you've already developed a module, we can link it to DBDP, and other people can fork your repositories from GitHub, build on them, and publish on them, cite them, and so on. You can just simply learn, go to DBDP Ed and read the blog posts and learn a little bit about different areas and perhaps contribute a blog post yourself. You can also write a case study. So if you have a publication where you've developed a digital biomarker and you want to show other people how to do this, CoLab is a really easy way to do that, as hopefully you're seeing. And then you can also contribute a blog post on the case study itself along with the paper. Right now, we're working on figuring out the best way to do data contributions. If you have data that you feel is truly de-identified, which we know is a huge challenge, so an example I would give of de-identified data might be that people come into the lab who have no other conditions, normal, healthy people that don't have any sort of characteristic signature we might expect, and they walk on a treadmill. And you don't have any other identifiers about these people. That could be de-identified data that we could feel confident in putting up on DHDR. Other data, we're still trying to figure out what would be a useful way to share. And again, thinking toward federated learning. So if anybody's working in that space, that would be another space we'd love to talk about. And we're also developing working groups on this, because this isn't something that as, even a group of 20 researchers and 10 collaborators who have been contributing to this, that doesn't capture what we need to capture with the entire community. So we really do want as many people as possible to get involved. So with that, again, the vision here is that we can use wearables to revolutionize healthcare. We can provide patient empowerment. We can develop precision therapies. We can develop adaptive just-in-time interventions and improve access to care. Everything underlying this is meaning that we're using digital health data to its maximal capacity. And the only way to do that is to work together. So, for those who may be in DC tomorrow, we are going to be talking in more detail about these CoLab notebooks, in more detail about how we actually implement this in clinical trials. And this would not have been possible without our amazing collaborators and the folks highlighted are bolded here who really contributed to this. And we had a great Halloween picture this year from my lab. So thanks, and I'll answer any questions. Yeah, Luca.
Okay. So first of all, this is fantastic. I was just talking to a friend the other day saying that we needed something like what you just built. So now I have a point to give out, and that's great. I have a reflection and then a question on where to take this forward. Regarding the data share piece and like truly the identified, I'm really with Ross here. Like there's no true identification, not even for healthy people, not even when you put the data, not even walking on the treadmill 5 days of Fitbits can identify you, with 99.9% accuracy within 1 million people. We're breathing that. You sharing that data with your employer, with your insurance company, with the clinical trials. You don't want those three people to come together, right? So I really think, there are data governance places out there that really makes you sign that no-way identification binding contract. That's all you need, right? Because there's no other way to go around that. I wonder if you are working with them or you're implementing that on your side. And then the question on like, where do we take this forward is you started just above or just below, I guess, the hardware. Like the firmware is not there. And as you said, hardware changes, firmware change. We don't see what's happening in the black box, and we're just left with data that changes. So how can we solve this? Like, should we think about open hardware? Is there someone that's thinking about open hardware? How to go in that direction?
You asked so many amazing questions. I'm trying to think of what order to answer them in. For open hardware, yes. I mean, the ideas there are great, sort of like democratizing the ability to build and deploy wearables. As we talk about, equitability and access is huge. And there are groups doing that. So there was a group that was a part of the NIH BD2K program called MD2K that was working at that. One of the huge problems, which I'm sure many of the industry folks in the room could tell us about, is the reliability of small batch hardware development. And so I do think that there is a huge benefit in leveraging existing industry that has already worked through a lot of those processes. So I think that there's room for both on that front. To the question of de-identification and re-identification and data sharing, I think you're right that having people sign these documents is one of the key aspects. One of the conversations that we've been having on this front is balancing the risk and the benefit of re-identification. So let's say that somebody does become re-identified. What does that mean in practice, right? It can mean a lot of different things. And so Leo Celli, who's also at the MIT Media Lab, recently put out a paper that was talking about this idea of balancing the risks and benefits. At the exact same time, we put out a paper that was more on the being careful, like being wary of the data sharing. And we had a lot of conversations back and forth that while our papers seemed to be telling different stories, ultimately the message was the same, which is that we cannot prevent the possibility that somebody is going to be re-identified. If we don't share data at all, we lose a whole lot of benefit that we could be seeing from wearables. So how do we come to this sort of risk-benefit trade-off to figure out, well, what is the level of risk that is acceptable to realize those benefits? And then as new technologies come online, like federated learning, like decentralized access to databases and so on, that we may be able to help to address that, but there's nothing preventing somebody from taking a screenshot of data, just doing a printout and taking a screenshot. So, you can think of so many workarounds, even when you try to build these safe harbor environments that are still not truly safe. And so I think, we need to continue that conversation. I think that answered all of your questions?
Yeah.
Okay. All right. Yeah.
On that line, is there, well, I think there's a wonderful opportunity with your platform to involve lawmakers, right, and to make them aware, because ultimately the data governance problem or challenge, I don't think we as scientists are capable of solving that. I think that needs to be solved on the law level.
Yeah, absolutely. Yeah.
Wonderful talk. Thank you so much. It did bring to mind from a different field. There's been a similar effort to sort of consolidate both data and code and learning. And I was wondering if your future plans for this would include, for one, sticking within this subfield, and then maybe collaborating with other fields to sort of leverage each other's strengths and weaknesses. And also, a second question tied to that is about how this separate entity were providing almost like a validation or certification of research studies and data, where you could get a DOI specifically for your data, or you could pre-register your experiments for scientific validity. So that two-part question, I'd love to hear your thoughts on that.
Yeah, this is great. To your first question about leveraging knowledge from other fields, I come from the bioinformatics community. So I did my PhD in genomics, epigenomics, and transcriptomics, so very different than what I'm doing now. But when I moved into the wearable space, it was obvious that we were missing something that the bioinformatics community had developed, which is these consensus methods to say, let's build upon each other's work rather than just doing a bunch of separate things in parallel. And they learned that the hard way. The imaging community, the same thing, right? And so we're in the early days of this type of work relative to these other communities, and there's a lot to learn. So, Bioconductor is a great example of a community that exists in that space where it's almost like you could think of DBDP as sort of parallel to Bioconductor, but in the digital health space. Yeah, exactly. So that's the exact idea. And we're not trying to reinvent the wheel on standards, on even data collection, like you were saying. Just trying to make things more centralized in a location. So, like you mentioned, it's sharing data and having a DOI for data sharing. We've been talking to some generalist repositories like Zenodo, like I guess Figshare wouldn't be a great one for this. Dataverse is another one where we're actually considering that being the route of data sharing, where you would just put a link to your data on the DBDP, and that would be a way to get it out, to also get recognition for when other people use your data, because it is a really valid resource that we should all be getting recognition for. So yes, the idea is, if anything here seems sort of repetitive with something that already exists, our goal would be to scrap it and to plug in the thing that already exists and works. So it really is, in an ideal world, a modular kind of built from existing resources toolkit. Mm-hmm. Yeah, Georgia.
So thank you very much for the talk. First of all, it was fantastic to learn about PDP and all the tools. I have two questions and observation. One was about the code actually that is shared there. So how do you manage if, what kind of license is there on this code if someone wants to take it for profit, and what can we do with that? And the second point was on sharing the data. I wanted to hear a little bit what you think of the approach, for example, of all of us who share this enormous amount of data with this peer approach, and that is a potential thing to be shared.
Yeah. Great question. Sorry, what was the first question one more time?
The first question was the code and how the license.
The license. So I think that we have moved, and I may be getting this wrong, so it's on the dbdp.org website, but we were on the Apache 2.0 and then moved to the MITCC BY, I think it was. So the idea there is that the code is free and open source for anyone to use, but not for commercial purposes. So that is one of the big challenges in this space also, is because we know that some of this stuff is sort of intuitive, right? And it's hard to regulate that. And that's something that I think, in talking about working groups and talking about what would it look like to kind of consider the long-term approach here, that would be a great topic for a working group, which would be, how do we envision the community using this, and do we envision almost like an open source software approach, and this is something that we've been pursuing these days, is so we're working with Chan Zuckerberg, who funded a lot of this work, in how they support like Matplotlib, Pandas, and a bunch of these different sort of Python environment. There's also the Mozilla framework. So there are a lot of predecessors to this idea that have made it work by developing open source software and having industry build upon it, but also support it. And so that could be a framework that we could consider as well. And your second question was about the all of us and the tiered access approach. So we've actually been working with the researcher workbench and kind of helping to develop more educational use cases on the Fitbit data. But I think the idea there is a good one, in thinking about combining ideas from this group on having people agree to only use data for certain purposes. And, when we have trusted partners, making sure that they can access the data at the resolution that would enable their work. One of the things I think we have to be really careful of in that approach is not allowing the rich to get richer. In the way that, when we say who is a trusted partner, what does it mean to be a trusted partner, and who are we leaving out in that process who could be really contributing? So again, like another potential topic for a working group of how to figure out what would this actually look like. But I think that there's a great opportunity to think through a process. And I probably have taken way more time than I should.
Perfect timing. Thank you so
Okay.
much.